So now we've had a look at using the sine rule to find unknown sides. Let's now have a look at it to find unknown angles. Now, finding unknown angles, we do need to be aware of something when we're working with the sine rule, in that we have to be aware of whether the triangle we're looking for, or the angle that we're looking for, is an acute angle or an obtuse angle. Or in some questions, like the question I'm going to go through, whether we actually have enough information in the first place to determine whether or not the triangle could be obtuse or acute. And there's just something subtle that we've got to do in each situation. So we just got to work through that. You'll see what I mean as I start working through. So here, it's described a triangle to me. Anytime it describes this, I highly recommend that you just start drawing out the information. So the measure of angle C in triangle ABC, if AC equals 7 centimeters, it wants me to find the measure of angle C. AB is equal to 11 centimeters and angle B measures 25 degrees. So I'm going to draw a triangle here which will show this quite nicely. Which we're going to look at initially the acute case. So I might actually just record that somewhere, that we're just going to have a look at the acute case. Like this. So with my triangle, it's up to me how I really label this. I'm just going to call this A, this B, and this here C. And now I need to substitute or plug in the information that I know. So the length AC is 7 centimeters. So let's just plug that one in here. The length of AB is 11 centimeters. So that will be this side just in here. And the angle at B is 25 degrees. So here it's 25 degrees, like that. And what we're looking for is the measure of angle C. So I'm just going to call this theta. So that way I've got something to play with here. Now, with the acute case, the reason why this is an acute case is because the angle at C, in the way that I've drawn it, is less than 90 degrees. All right. And I can actually draw this triangle in a way where that's not less than 90 degrees, and I'll do that in a moment. But anyway, let's have a look at the sine rule and how we'd go about answering this. So we've got our triangle already labeled ABC for us. So let's just quickly put our side lengths as ABC. So the 7 centimeters will be the B, 11 is the C. And we can quickly identify the information that we have here. So we've got the pairs that we're interested in is B and C. So our side length of B is 7 centimeters. Our side length of C is 11 centimeters. Our angle at B is 25 degrees. And our angle at C is what we're looking for, which we've made theta. So now what we do here is we go up to our ratio formulas up the top here. We're interested in the B and C. And because I'm trying to find C, I'm actually just going to list that one first. But we ignore the A part of it, essentially. So let's write down our formula here. So we know that the sine of our angle of C divided by C is going to be equal to the sine of our angle at B divided by B. So now we substitute our information in. So looking at this, this is going to be our sine of our unknown angle divided by 11 will equal our sine of 25 divided by, what have we got? 7. So we rearrange to solve this. So because we're dividing by 11, we've got to multiply both sides by 11 here. And that will give us the sine of our angle is equal to 11 times all of this. So that'll be 11 sine 25, all divided by 7. But I don't want the sine of my angle. I do want just the angle itself. So the angle itself will be the sine inverse of whatever's on the other side, which will be 11 sine 25 over 7, like so. So that means my angle, when I plug it in, is going to be approximately 41.6 degrees. All right, and that there is how we find it if it's the acute case. Now, I say all this because the obtuse case is something that we also need to consider. So I could draw this same triangle, but rather than make this clearly less than 90 degrees, I can draw the same triangle with the same information and look at a case where it's greater than 90 degrees. So let's say I drew the triangle like this. Hang on. Where this was the angle C, so that's my theta angle. I'll still have my side of A here and my side of B here. So this will be 11 centimeters, this is 7 centimeters. And you can now see that, oh yeah, and this is 25 degrees. That's right. But you can now see that I've actually drawn the same triangle with the same information that we had on here, but I've now created an angle at C that's greater than 90 degrees. Now, this is important to consider this case because we didn't actually have enough information given to us to know whether or not we had the obtuse case or the acute case. Now, sometimes we might be given enough information, and if we are, then we just need to identify whether or not the angle that we're looking for is acute or obtuse, because if it is acute, then there's something extra that you need to do with this process. So let's just start by looking at, how would we, go through the step-by-step of identifying the angle first. So the first step would be to label our triangle. So this would be A, this would be B again, this would be C. And we could record all the information down, but our information is actually identical as what we had before, and the formula we're going to use is identical. So I'm just going to quickly write the formula down. So this sine of the angle at C divided by C is equal to the sine of the angle at B divided by B. And we can substitute our information in here. So this will be the sine of our unknown angle is equal to our side of 11. So divided by a side of 11. And then sine of 25 divided by 7. So we're at that same sort of spot. And initially what we actually need to do is the same thing that we did before. So we'd multiply both sides by 11, which will give us sine of our angle will equal 11 times sine of 25 over 7. All right, and then we need to find our angle. However, we need to be very careful in this because our calculators, when we do this sine inverse thing, so theta equals the sine inverse of all of this stuff. The problem with just doing that is that our calculator will only find the acute angle. It won't actually find the obtuse angle for us when we do the sine inverse. So we've got to use some properties that we've looked at briefly before to be able to actually answer this question. So let's just consider our unit circle for a moment. What does finding the sine of an angle actually represent? Well, back in our unit circle, if you remember, when we go around our point to our point P, anywhere around this unit circle here in relation to some kind of angle. All right, our cos of that angle will be our x coordinate. Our sine of that angle in here will be our y coordinate. Now on this side, if we actually draw the same line segment out to our unit circle with that same angle of theta in here, I just haven't included that information, but that would be theta. All right, essentially what this has to be, if this is theta, is 180 minus theta. All right, which means that to find the x coordinate and y coordinate here, we'd have to do the cosine for the x of 180 minus theta and the sine of the y of 180 minus theta. But what's key here is the actual y coordinate that we would have at this point and this point is the same. So what we can say here is the sine of theta, this here, is actually equal to the sine of 180 minus theta because they find the same y coordinate. And that's the key thing that we need here is we need to know that 180 minus theta will give us the same angle, but what it'll actually find is the obtuse angle. And that's what we need to do when we come back to this. We need to realize that we've got an obtuse case, and you'll generally see that on your diagram. All right, but we've got an obtuse case here that we've got to consider. So we've got to go 180 minus all of this. So sine inverse of 11 sine 25, all divided by 7 to find this. Now, obviously, I've already done the sine inverse of all this. That was 41.6. So because I've done that, I've just got to go 180 minus 41.6, which will give me, so my theta is going to be approximately equal to 138.4 degrees. So the key here is we do have to, with this rule, identify whether or not we've got an acute case and an obtuse case. If you've got the acute case, great. Just substitute in the formula, work your way through till you've got theta is equal to this sine inverse and plug it into your calculator. If you have the obtuse case, however, you've got that one little step here that you've got to be aware of, and you'll see that you've got the obtuse case generally on your diagram that you're drawing here, because that'll be greater than 90 degrees, which means that when we do this sine inverse step, you've got to subtract that all away from 180, and you would find what that obtuse angle is equal to.